Before studying weight training, we should take a look at the types of strength we are trying to develop with these exercises. There are three primary types of strength that are developed through weight training. Absolute strength is the ability to produce large forces regardless of speed of movement. Absolute strength exercises use heavy loads and slow speeds of movement. This type of strength is an important foundation for other types of strength. It's important even in sports that have high speeds of movement. The musculoskeletal system works as a system of third-class levers. Soundly anchoring the fulcrums of these levers increases their ability to apply force. Absolute strength is an important component of this anchoring ability. Power is the ability to produce force quickly. Power is a combination of speed and strength, and power training exercises require high speeds of movement and light loads. Power is critical in any sport that has a speed component. Reactive strength is the ability to produce force using the muscle's stretch reflex. When muscles are quickly stretched just before contraction, they snap back like rubber bands, enhancing the force produced. This force increase is called elastic energy, and reactive strength is sometimes termed elastic strength. Reactive strength activities involve high speeds of movement and eccentric muscle stretching activities such as jumping. Weight training exercises for sports performance can be classified into four categories. These categories are the Olympic lifts, the static lifts, the ballistic lifts, and the bodybuilding lifts. Olympic lifts are the competitive lifts, the clean, jerk, and snatch. They also consist of other exercises that are derivatives of these or exercises that might serve as teaching progressions for these. These lifts should be the foundation of any sports performance weight training program. As the bar slowly leaves the floor, these lifts train absolute strength. As the bar speeds up, power is developed. As the bar is caught, amortization occurs and reactive strength is trained. The inclusion of all of these types of strength in one exercise make the Olympic lifts great developers of complex strength, and the body length shifting they require enhances coordination. If these are done correctly, the joint firing patterns are very similar to those found in running, jumping, and changing direction, so they show great transfer into the sports themselves. The need to maintain ideal postural alignments during these exercises makes them great developers of core strength and postural strength. Olympic lifts stimulate the endocrine system. These hormonal changes assist in speed development and other forms of strength development. Much of this endocrine stimulation occurs as a result of the buildup of mild to moderate levels of lactate during the workout. These lifts have no negative effects when properly scheduled. Static lifts are lifts that feature the use of major muscle groups, simple, gross movements, high resistances, slow speeds of movement, and usually large ranges of motion. Most static lifts take the form of squats or presses. These lifts develop absolute strength as a result of the relatively heavy loading. This loading also increases the postural demand, so these lifts are great developers of postural strength, provided technique is not compromised as load increases. When done using large ranges of motion, they feature strength development in a balanced way, producing the proper ratios of core strength to peripheral strength. They also produce huge positive endocrine changes because of the large number of fibers involved in these lifts. Also, these lifts are done relatively slowly, keeping the muscle fiber under tension for long periods of time, further enhancing this endocrine development. These lifts may show some negative effects. They produce short-term mobility and coordination losses, so using these lifts at times when critical competitions are near might not be a good idea. They also might produce increases in muscle size in some individuals, which may or may not be desired depending upon the sport. The ballistic lifts are lifts that involve major muscle groups, gross, simple movements, high speeds, low resistances, a high eccentric component, and usually employ small ranges of motion. These lifts typically employ jumping or bouncy, repetitive movements such as weighted jumps and speed presses. These exercises enhance absolute strength and develop reactive strength. They also produce some limited endocrine stimulation as a result of the intensity of the lifts and the lactate production that results from the exercises. While there are no negative effects when scheduled and administered properly, these lifts should be reserved for older athletes because of the inherent risks involved with impact and spinal loading under impact. Bodybuilding lifts are lifts that emphasize smaller muscle groups and at times use more precise movements with higher technical demand. Sometimes these exercises resemble the sport for which the athlete trains. They are done with light loads, high numbers of repetitions in each set, and short recovery times. For this reason, they are usually done in circuit or stage formats. Bodybuilding lifts are so named not because of any relationship to the sport of competitive bodybuilding, but because of the accelerated recovery from exercise that they produce. These exercises establish high levels of endocrine stimulation and also stimulate the body's recovery processes. For this reason, they are often used in restorative or recovery-themed training sessions. Combined with proper nutrition, they are probably the best way to replenish and enhance glycogen levels. For this reason, this work is critical in endurance sports. The higher technical and coordination demands of the exercises enable development of sport-specific strength as well, and often these exercises are chosen to address the typical problem spots and injuries that each sport has. For example, hamstring work is often included in bodybuilding work for track athletes because of the frequency of hamstring injuries in that sport. Because they are difficult to include in other forms of weight training, rotational exercises are often found in bodybuilding circuits. There are no negative effects to these lifts when they are properly scheduled. However, they might produce increases in muscle size in some individuals, which may or may not be desired depending upon the sport. In this section, we will assemble teaching progressions for the Olympic lifts. Before we do, let's examine some of the differences between training for weightlifting competition and using the Olympic lifts to train for speed, power, and sports performance. First of all, the extension of the hips is the most powerful movement the body can produce. This extension is critical in all sports. Our teaching progression will be built to ensure that the extension of the hips is done properly and is timed correctly, since this is the element that most carries over into sports performance. Small errors in other areas can be tolerated in non-competitive weight training, but this must be correct. Secondly, in this system, the lifter rests in the standing position. When Olympic lifters do a set of 3 reps, for example, they drop the bar to the floor, relax, and reset after each repetition. Releasing the weight allows the body to relax in a chemical sense. For this reason, in this system, we will teach the lifter to relax and reset between repetitions with the bar at the waist, and the lifter is not allowed to release the bar until the set is done. This improves the production of proper blood chemistry to foster additional strength gains. Finally, in this system, the catch positions are higher. The deep catch positions and deep squat positions used in competitive lifting are not needed when using Olympic lifts to train speed and power. This is not to say that deep positions are not important in training, but it's not necessary to accomplish them here if competitive weightlifting is not the goal. Now, let's examine the teaching progressions for the Olympic lifts. There are 7 steps to this teaching progression. First, the setup is taught. Secondly, the deadlift is taught to introduce the beginning of the pull. Third, the tap is taught to ensure the proper shifting of body parts to enable the hips to extend. Fourth, the pull is taught. Fifth, time is taken to polish or correct the pull. Our focus up to now has been on the shifting of body segments, and this gives us a chance to correct and adjust any other aspects of pulling mechanics that need repair. Sixth, the skill is diversified as different grips and levels of lifting are introduced. Finally, after the pulling movement is correct and stable, the catches are taught. Note that the weights used in these progressions should be very light, regardless of the age or level of the athlete. This enables technique to be the focus and eliminates the load as a distraction. Light bars or alternative equipment might be needed with some. Patience and conservative choices here set up faster improvement and better long-term results. In the setup, the feet are positioned so that the top of the shoestrings are directly under the bar. The feet are placed about shoulder width apart. The lifter is required to preset the back. This means the lower back is tightened and held straight before the lifter lowers to grasp the bar. Setting the back before descent is easier to learn and makes a point of this key component of safety and technique. The hips and knees flex as the lifter lowers, and the back is held straight so that when the bar is grasped, the shoulders are directly over the bar. Note the hips and knees are both flexed here. It's a common error to flex only the hips, placing strain on the lower back. The bar is gripped with the thumbs in opposition. Once the grip is assumed, the wrists are curled, flexed slightly to enable better acceleration of the weight. Placing the index finger over the thumb in a hook grip is an option to improve the grip, but when significant weight is lifted, straps are necessary. Grip widths vary from exercise to exercise, but for now, a shoulder width grip is used so that the arms are just outside the legs. The next step is teaching the deadlift. The lifter must bring the bar from the middle of the shins to the middle of the thighs, while keeping the shoulders over the toes, the back straight and inclined forward, and the head in line with the spine. The lifter must finish with the butt out and the knees slightly flexed. The bar is about an inch away from the thighs. The lifter pauses in this position for a second or two before lowering. This pause enables the lifter to check body positions. The most critical point is keeping the shoulders out over the toes while rising. It's a common error for the shoulders to move back as the lifter rises. Also note the arms remain extended at all times. Sets of 5 repetitions are a good format to begin with. The tap is taught next. After the deadlift and the pause at the top is done, the lifter moves the thighs forward so that they actually strike the bar, forcing it forward. This teaches the shift needed to extend the hips. It's critical that the lifter does not rise and keeps the shoulders out over the bar until the tap occurs. Also note the arms remain extended at all times. Sets of 5 repetitions are a good format to begin with. Once the lifter can deadlift, pause, and tap, the pull is taught. The pull is a vertical pulling movement initiated in the shoulders, finishing with the elbows high and the body extended. It's critical that the lifter pull only after the tap is complete. These events must happen in sequence, not simultaneously. Notice here how at the end of the tap the arms are still extended, indicating the pull has not yet begun. After the lift is completed, the bar is returned to waist level and the lifter recovers, resets the back, then lowers for the next repetition. Next, the pull is polished. This requires several small adjustments. First, the pause at the top of the deadlift just prior to the tap is eliminated. Care must be taken here to accelerate the bar consistently and to prevent premature high bar speeds. The bar should be kept moving very slowly off the ground and should accelerate abruptly only after the tap. Secondly, the striking of the bar in the tap becomes a brush of the bar. as the lifter is taught to move the knees down and under the bar as the thighs move forward. Note how the bar no longer taps the thighs, but rather brushes against them. Next, the pull is diversified. The snatch requires a very wide grip, so pulls are then taught and done using a very wide grip in anticipation of teaching the snatch. The pull is also taught from various depths. The mid-shin starting position we have been using is called the floor position. It is so called because with typically sized weight plates, the lifter will allow the plate to touch but not rest on the floor between repetitions. The next level taught is lifting from the knee. Lifting from the knee actually requires starting from a point just below the knees. Here, the lifter begins from the midpoint of the deadlift, but should execute the top part of the lift in the same way. The next level taught is lifting from the thigh. Lifting from the thigh allows the lifter to begin the lift in position to execute the tap. Care must be taken in working from the thigh that the shoulders are out over the toes at the start of the lift and that the mechanics of the pull used in work at other depths are preserved. The coach should work the athlete at all three levels using both grips, the wide snatch grip and the closer clean grip. When teaching beginners, it typically takes 2 to 3 sessions to get them to execute the pulls correctly. Pulls are then done for about 3 weeks. During this time, the lifters are also taught the front squat and the snatch squat. This is done so that when the time comes to teach the catches for the clean and snatch, the lifter already has familiarity with those positions and teaching them becomes simpler. Note in the front squat the high elbows, forward head, and how the bar sits high on the chest. The athlete should not be allowed to compromise this grip or position, as many beginners do not have the upper body flexibility needed to achieve these positions. Note in the snatch squat the wide grip and increasing forwardness of the head as descent occurs. Approach this lift with very conservative loads and be persistent as technique improves and control and flexibility gains are made. The catches are taught only after many correct repetitions of the pulls have been done. There are 3 steps to teaching either catch. They are spotted hand catches, spotted bar catches, and spotted cleans and snatches. In spotted hand catches, the lifter raises the elbows and the coach holds the lifter's hands. The lifter is told to move the arms into the catch position and squat on the go signal. The coach can actively move the arms to enable the lifter to feel the quickness necessary. Here you can see the spotted hand cleans. Here are spotted hand snatches. The lifter is being told to simultaneously extend the arms and squat on the go signal. Also notice the wider grip. Next step in the teaching progression for the catches is the spotted bar catch. In this exercise, the same movements are used, but the lifter uses a bar and begins to understand moving about the bar. The coach here is actually bearing the weight of the bar for the lifter. Here are spotted cleans. Notice that the coach steps in and assists the lifter in stabilizing the bar at the top of the lift. The athlete must be told beforehand that the coach will do this so that the lifter isn't startled. Spotted snatches can be done in the same way. Again, notice the wide grip. Finally, using a very conservative weight, the lifter is allowed to execute the clean and snatch catches. The lifter is required to bend the knees slightly upon catching the weight to initiate the teaching of amortization. Even when the knee flexion is mistimed with beginners, simply requiring it is enough to place the lifter on the path to develop a good amortization during the catch. Deep catches, while not necessary, can be used as a drill from time to time. It should be noted that good lifters create high forces and as a result might leave the ground for an instant at the end of the pull. When they land, a loud noise may be made. This results from the forces produced and should not be a goal unto itself. Teaching lifters to stomp the feet at landing is questionable at best. It produces concentric work when isometric preparation and eccentric work should be occurring. Correct amortization and reactive strength gains suffer and injuries may result. These movements are inherent and very natural, and frankly, the best coaching practice is typically not to address them at all. A good training program will include the pull, the clean, and the snatch from the floor, the knee, and thigh levels. As before, sets of 5 with very conservative loads are a good way to start. The squat is the fundamental developer of absolute strength in this and many systems. The vast numbers of muscle fibers involved, as well as the high tensions and times under tension applied to these fibers, produce huge neuromuscular and endocrine changes. The depth of the squat is an important factor, and the proper depth should be required with each repetition. For this reason, in this system, a target is used whenever deep squatting is employed. In this case, a box is used, but a rubber band stretched across the rack can be used if preferred. Note that this is not a true box squat, as the lifter touches the box very lightly and never rests upon it. This preserves the eccentric component of the lift and actually improves technique, since now the lifter must decelerate prior to achieving maximum depth. This produces much better acceleration and deceleration patterns of the bar. The bar must slow progressively before it comes to a stop and reverses direction, and much coaching attention should be paid to proper bar speeds in descent. The fundamental type of squat used is the deep back squat shown here, using deep, including subparallel positions and full ranges of motion, increases the amount of muscle tissue activated, engages all muscles, and ensures proper strength balances between the body's core and periphery. Teaching the setup for the squat should not be neglected. The lifter should use the knurl marks on the bar to make sure the grip is symmetrical and the head centered. The lifter raises the bar from the cups using a parallel stance and then walks back. Poor back alignment here may result in injury. The bar should sit high on the trapezius muscles. Padding on the bar is not advised, as the added thickness places the bar too far backward and destroys proper biomechanics of the lift. The lifter should be taught to preset the back before descent by tensing the lumbar spine. The lower back should not be overarched. The head should be upright but not tilted back. Looking up or tilting the head back is not an effective way to create better back alignment. The feet should be shoulder width apart with the toes turned slightly outward. The squat is initiated by flexion of the hips. Initiation by knee flexion is a common error. Forward movement of the knees should not be excessive. The knees moving excessively in front of the toes is a sign of this mistake. Taking the hips backward is the desired movement. In this teaching system, it is often unnecessary to address this key component because the presence of the target behind the lifter and the need to touch the target presents a more accurate perception of this motor task to the lifter. The ascent is initiated by extending the hips. The feet should remain flat, and if the lifter has difficulty with this, the coach should work patiently toward this goal while flexibility levels improve, particularly those in the ankle. Resist the temptation to place something under the heels to elevate them. This plantar flexion forces the leg joints to fire out of sequence. A small weight plate placed under the toes, however, can be used occasionally to enhance Achilles unit strength and ankle flexibility. A key technical component of the squat is the abduction and adduction of the thighs. As the lifter lowers, the knee should spread smoothly and significantly. This creates an anatomical opening for the hips to lower and enables the lifter to keep the torso more upright during descent. Nearly all difficulties in keeping the torso up are related to failure to widen the knees enough during descent. The knees must achieve a position wider than the feet. At the bottom, with heavier weights, when starting to rise, the lifter should push up, but also slightly outward with the knees. During ascent, the knees should move slowly together toward the midline of the body. A common error is closing the knees before rising. A slight delay should occur before the knees move together. The remedial dumbbell squat shown here is a good way to teach the widening of the knees needed in descent. The positions of the arms practically force the knees to widen appropriately. This exercise can also be used as a primary squat exercise for the developmental athlete. The bench press is the most common developer of absolute strength employed for the upper body. We will examine the bench press, but the principles discussed here can be applied to any press exercise. The lifter should use the knurl marks to ensure the grip is symmetrical, and the thumb should grip the bar in opposition to the fingers. Grip width varies with each individual according to anatomical variances, but the grip should be adjusted so that at the sticking point, the most difficult part of the lift, the forearms are vertical. This best enables the forces produced in the shoulders to be transmitted along the long axis of the forearms to the bar. Locating the lifter on the bench is one of the more misunderstood aspects of the bench press. The lifter's eyes or forehead should be located directly under the bar. It's a common error to locate too close to the standards. If the lifter is properly located, assistance will be needed to move the bar off the standards and into position to execute the exercise. The target for the descent should be just above the nipples. The direction of maximal force production capability is primarily vertical, but there should be a slight horizontal component with the bar moving slightly towards the head. This is why positioning on the bench is so critical, because if the lifter is too close to the standards, the horizontal component cannot take place and force production capabilities diminish. Please note that in this video, the forward movement is slightly exaggerated for clarity. Note the wrist should be flexed throughout so that the point of force application is the palm of the hand. A common error is applying force at the intersection of the thumb and the first finger. It should be noted that for athletes who use overhand throwing movements, the use of pressing activities should be limited. These activities, when overused, can overdevelop the deltoid, resulting in impingement syndromes. Also of concern is the fact that the nature of the exercise when pressing bars limits full ranges of motion. For this reason, pressing with dumbbells is sometimes a good substitute. We will now examine teaching guidelines for split position lifts. Split position lifts include all lunging and squatting movements done from a staggered stance, as well as split catches in the split clean and split snatch exercises. These lifts are valuable because they are very specific to running and jumping activities, but they must be done correctly, as incorrect technique promotes patellar issues and a variety of other knee ailments. In split position lifts, the stance should be very wide, usually as wide as comfortably possible. This enables preservation of good pelvic alignment while descending. A wide base enables the pelvis to maintain a neutral alignment with respect to the spine, while a close stance forces the pelvis into anterior tilt during descent. When performing lunging activities, large steps should be taken for the same purpose. During the descent and ascent, body weight should be centered above a point between the feet. It is a common error to shift body weight forward, placing undue stress on the patellar unit. As a general rule, the knee should not extend beyond the toe at any point in the lift. In lunge walks, the descent should occur with body weight centered between the feet, and most of the ascent should be vertical before proceeding forward. Here we will discuss general guidelines for assembling the weight training program. These general guidelines are far more important than the details of exercise choice and set and rep progression, and usually failed programs result from failure to adhere to guidelines like these. First, progress loading patiently and avoid preconceived notions about the amount of weight athletes should do. Choosing light loads early, even with talented athletes, enables good technique to be learned and sets up a steep improvement curve. Progressing patiently ensures long-term progress and prevents injury. Olympic lifts are the fundamental lifts of any program, and significant volumes of Olympic lifts will be part of the program throughout the training year, including the competitive season. Typical volumes are 5 to 8 sets, 2 to 3 times per week. Start with a few exercises and then diversify. Certain sessions early in the training year might use only 3 exercises. Start with simple exercises and double leg or double arm work, and then include more complex single leg and arm work later if the sport requires such. Keep power levels up throughout the workout. Choose weights so that the work levels and bar speeds remain consistent. Too much fatigue too early destroys the session. Employing large ranges of motion strengthen the body in better balance and establish better strength ratios between the core and periphery of the body. Using high speeds of movement in the weight room is sometimes an exception to our full range of motion rule. Full ranges of motion at high speeds involve too much muscle tissue and produce fatigue too fast, decreasing power output and velocity. Temper high-intensity work with low-intensity work. Avoid back-to-back high-intensity sessions and include 1 or 2 lower-intensity, more volume-oriented sessions between them. This provides the metabolic and endocrine support needed to foster recovery from those intense sessions. Don't be enslaved by percentages. It's more important to watch the workout than write the workout. Percentages might be a good place to start, but approach each session and exercise with an idea of the exertion level and bar speed the athlete should show, and then make adjustments. If training is done prior to the weight session, the resulting fatigue makes percentages inaccurate. When athletes enter the weight room fatigued, using lighter weights to ensure proper levels of exertion and bar speeds produces much better results and does not harm the athlete's speed and power levels. Generally speaking, when putting together a strength development program, general strength, power, absolute strength, and reactive strength must be constantly developed. When we look at advanced levels of training in each of these categories, though, there is a specific sequence that should be followed over the course of the training year. First, a strong base of general strength should be developed using a variety of bodyweight exercises. While not our primary topic here, a foundation here is prerequisite to a weight training program. This is not to say that weight training can't be done on the first day of training or at young ages, but before heavy weights are lifted, general strength should be established. Next in the training plan comes power development. The key lifts here employ high speeds of movement and lighter resistances. Next in the plan comes absolute strength, and static lifts take priority. Static lifts can be done earlier, but using heavy loads is delayed until power training has taken place. It is important to note that power is placed before absolute strength because of its positive effects in training the nervous system, improving recruitment and rate coding characteristics. This makes the body much more receptive for the speed and absolute strength training which come afterwards. This also makes the absolute strength development phase more efficient, so more gains can be made in a shorter time, limiting the coordination and mobility losses that are associated with the static lifts. Finally, reactive strength can be trained using more advanced plyometrics and ballistic lifts. While simple jumps can be done with anyone, be sure adequate strength levels are established before undertaking intense plyometrics or ballistic lifts. There are 4 types of weight training sessions employed in this system. The first is called a neuromuscular workout. It is composed of Olympic lifts, static or ballistic lifts for the lower body, and static or ballistic lifts for the upper body. Typically only one Olympic lift is chosen. although different lifting levels or depths may be used. This enables the lifter to achieve a better rhythm than that which can be achieved using various exercises. 5 to 8 sets are used. When examining the static or ballistic components for the lower and upper body, approximately 30 or 45 total repetitions are done using 1 or 2 exercises. 30 repetitions are used for sprinters, hurdlers, basketball players, volleyball players, football skill players, and other slender body types. 45 repetitions are used for throwers, football linemen, and other more muscular body types. At certain times of the year, a rotational lift may be added at the end of the session. The second type of session is a bodybuilding session. These sessions usually contain 24 sets of bodybuilding exercises. These exercises may not all be different, some may repeat. The third type of session is a transition session. A transition session contains Olympic lifts and bodybuilding exercises. In a transition session, 5 to 8 sets of Olympic lifts and approximately 24 sets of bodybuilding exercises are used. A variation of the neuromuscular session containing only Olympic lifts is also useful in special situations. Compatible training is a big issue. These types of weight training sessions are designed to be combined into the same training session as certain other types of work in a way that is physiologically compatible. Neuromuscular weight training sessions should be combined with acceleration training, maximal velocity training, multi-jump training, or multi-throw training. Bodybuilding sessions should be combined with general strength training, medicine ball exercises, submaximal running, or agility work. Transition sessions are done in the same combinations as are the neuromuscular sessions, but in special situations. Olympic lifting units should contain 5 to 8 sets of 1 to 5 repetitions with intensities ranging from 50 to 100% of single rep max. Approximately 50% of all training sessions, meaning any type of training, should contain an Olympic lifting unit. In this training system, Olympic training units take 3 forms. The first is a power training format. Here the athlete uses 4 or 5 repetitions at 50 to 60%. Recoveries are nearly but not quite complete as slight lactate buildup stimulates biochemical responses and enhances the workout. Placing athletes in groups of 3 creates near-perfect recovery intervals, groups of 4 allow too much rest, and groups of 2 produce too much fatigue if work is continuous. The second form is training rate of force development. Here the athlete, after warm-up sets, uses 1 or 2 repetitions at 90 to 100%. Recoveries are long. These sessions must be tempered with periodic power format sessions. The third format is a transition theme that bridges the gap between these 2 types of work. Static lifting units contain 4 to 6 sets of 4 to 8 repetitions with intensities ranging from 30 to 90% of single rep max. Recoveries are long. Approximately 30 to 50% of all training sessions should contain a static lifting unit when the time of year is appropriate for this type of work. In this training system, static lifts progress patiently in intensity. In most situations, 8 reps per set is a starting point, progressing to 6, then 5 as intensities increase. When the work becomes intense, this work must be tempered with lighter, higher repetition work to foster recovery. At the most intense training times, training should diversify to prevent injuries. Intense statics should be done after the Olympic power format phase, and the amount of the training year spent doing intense statics depends upon training age. Older athletes regain strength faster than younger athletes develop it, so they spend less time doing this type of work. Ballistic lifting units should contain 4 to 6 sets of 5 to 12 repetitions, with intensities ranging from 10 to 30% of the athlete's body weight. Recoveries are nearly but not quite complete. Approximately 10 to 30% of all training sessions should contain a ballistic lifting unit when the time of year is appropriate for this type of work. These lifts are a good way to enhance and maintain strength when statics are discontinued. The reduced time under tension the muscle fibers experience produces less reduction in coordination and mobility. These also fit well into the general prep phase of high training age athletes. Bodybuilding lifting units should contain about 24 sets of 10 to 12 repetitions with intensities ranging from 60 to 75% of single rep max. If intensity is correct, the athlete should sense fatigue on the final repetition. Recoveries must be less than 90 seconds to achieve the proper endocrine effects. Approximately 30 to 50% of all training sessions should contain a bodybuilding lifting unit at peak usage. These lifts should be used frequently early to establish endocrine profiles conducive to recovery. Bodybuilding can be used as needed at any time of the year for the same reasons. Bodybuilding is also critical in endurance sports as it improves muscle glycogen levels. In this training system, bodybuilding is used to ease the transition when static lifts are discontinued. In the general preparation phase of training, the Olympic lifting sessions should consist exclusively of the power format. Simple movements and only one primary exercise should be employed. The static lifting program should progress very patiently and not exceed intensities of about 70% while power development is being prioritized. Double leg and double arm lifts are used, usually only one of each per session. Ballistic lifts are typically absent in the general preparation phase, but might take the place of some static lifts with high training age athletes. Bodybuilding should occur frequently, especially with younger athletes, to set positive endocrine profiles. In the specific preparation phase of training, every second or third Olympic session is a more intense one, using a transition format and progressively increasing intensity so that lifting to develop rate of force development begins near the end of this phase. The other Olympic sessions follow the power format as review and to provide endocrine support for more intense sessions. A varied finish lift such as a jerk, a snatch squat, or a front squat may be used to complicate the set. In the static lifting program, every second or third session consists of double leg and double arm work, progressing in intensity as repetitions decrease. The other sessions employ less intensity, higher repetitions, and typically use 2 exercises. Single leg or single arm work is used in these sessions. In general preparation, most of our rotational exercises are included in the bodybuilding work. The decrease in bodybuilding in this phase, along with the need to increase intensities, requires inclusion of a rotational lift in neuromuscular sessions in this phase. Ballistic lifts may continue in limited amounts with older athletes. Bodybuilding volumes decrease greatly but remain part of the program throughout this phase. In the pre-competition phase of training, Olympic lifting sessions are a mix of power and rate of force development formats. An Olympic-only session can be used as well, especially the day prior to competition. The static lifts are discontinued because of the onset of competition and their temporary negative side effects. Younger athletes are exceptions to this rule and usually continue static lifts in this phase. As the statics are discontinued, ballistics appear regularly to enhance and maintain the strength gained previously. Bodybuilding also appears in transition-themed sessions as a way to ease the transition from static lifts. A neuromuscular session containing Olympics and ballistics, as well as a transition-themed session containing Olympics and bodybuilding, are staples in this phase. In the competition phase, peaking is a prime concern. Olympic lifting sessions continue, but volumes and densities decrease. The power format is used most frequently, but in the absence of regular competition, rate of force development sessions can be used. Sessions consisting only of Olympic lifts are common in this phase. Static lifts are not done. Ballistic lifts are used, particularly in the absence of regular competition. Bodybuilding is done as needed to maintain endocrine support and battle sluggishness. In order to monitor progress in the weight room, it's necessary to devise a safe and accurate testing procedure. In this system, multiple repetition max tests are used to project a single rep max. The clean and deep squat are the most critical lifts to monitor. The coach assigns a weight for the athlete to do during the test. The athlete then does as many reps with the weight as possible. Then a projected single rep max is determined mathematically from the weight and repetition data using the chart shown here. For example, if an athlete cleans 170 pounds 6 times, 170 divided by 0.85 yields a projected max of 200 pounds. In the early stages of training, the coach chooses lighter weights, permitting more repetitions and greater safety. In the latter stages of training, the coach chooses heavier weights and the test more resembles a true maximum test. The test ends when failure occurs, or if the coach deems technique to be poor, or if 12 repetitions are done. This is because the test loses accuracy above the 12 repetition threshold. It's most important to understand that this number might not indicate that the athlete can single rep max that amount on that day, but it is an indicator of progress, and the projected maximum becomes a target to achieve in actuality later in the year. Typically, these projected maximums increase only with young athletes who improve very quickly. Older athletes should measure progress in their ability to maintain and eventually consummate the actual maximums. We will now display again the rep and percentage chart for your convenience and for ease in duplication.